For this video, I'm going to go through a paper 2 style question for geometry, for the 3D geometry. And I mainly want to focus on surface area and volume, but I will go through the other parts just to show you how they're useful to use. And it's a quick review as well on finding missing lengths and angles. And how to deal with these long questions. So we have a square-based right pyramid. It's really important to realize that students do actually miss out on this idea of a square base. Sometimes it's useful, sometimes it's not, but keep an eye for it. And then you have a right pyramid A, B, C, D, V. So A, B, C, D, V, it's a right pyramid. The idea of it being right is that it's not skewed, so it doesn't go there, so it's a right pyramid. The midpoint of DC is M, so that's the midpoint, and VM is inclined at 65 to the base. So VM is this line, which is not straight. VM is this line, and the angle 65 now could be here, and it could be here, but the angle that is inclined to the base is this angle. So actually 65 is the angle at the bottom. So you need to be aware of this type of language that they use in a question. So this will be our 65 degree. The sides of the base are 8, and O is the center of the base. So part A asks you to find the height of the pyramid, giving the answer correct to 3 significant figures. So we want VO. So for part A, we want VO. And VO is basically taking this triangle VMO. So we have the triangle VMO, and we have a 65 angle here. We have the base of 4. The reason it's 4 is because you're taking half of AD. You're looking at half the length here. So the length across is 8, and then you're just taking half of it. It's not half the diagonal. If it was half the diagonal, if we're looking at this, then it's a completely different length. But it's half of 8. So this will be 4, and then the length we're looking at is the height, so we're missing the length here. And you can label the triangle now. So we have the hypotenuse, we have the adjacent, and we have the opposites. So obviously we'll have to use one of the trig ratios. I'm just going to write them at the top to have them there. Just for reference. So we have the angle, we need the opposite, and we have the adjacent, so we'll have to use tan in this case. So tan 65 is equal to the opposite, which we're missing. I'm going to write it as VO divided by the adjacent, which is 4. And so we need to cross multiply. So the vertical height is tan 65 times 4. Make sure your calculators are on degree, and this should give you 8.58 centimeters, and that's the 3 significant figures. So that's the height, and that will be useful. You'll notice that they tend not to pick just random numbers. You'll be using this quite frequently. For part B, calculate the length of VM. So VM in this case is the inclined height, so it's not the vertical height, it's the inclined height. And again, we'll be using the triangle VMO. We won't be using the VO, the vertical height. We can use VO and this 4 and then use Pythagoras. The reason we tend to avoid that is because you might have made a mistake here and you might have rounded this too much that it might change the answer to VM. So we tend to like to use values that are already in the question and not reuse values that we've already found unless it's necessary. So we will be using VM and VO in the other parts of the questions. But if you can avoid using them, that would be great. So we have this triangle again, so that's 65. The base is 4, we have the height as 8.58, and we're missing the hypotenuse. So we can use one of the trig ratios, and in this case this is the adjacent again, and so we want to use cos because we have the adjacent, we're missing the hypotenuse. So cos of 65 is the adjacent, just 4 divided by the hypotenuse, which we're missing as Vm. And so Vm is equal to 4 divided by cos 65, which is 9.46 centimeters. And that's Vm, so that's going to be useful for us later on. So that's 9.46, and this was 8.58. Now, for part II, they want the size of the angle DVC. The angle DVC is not part of a right angle triangle. So go up, VC, they actually want this angle. And it's not part of a right angle triangle. Unless it's made obvious to you, do not assume they have a right angle triangle. So I'm just going to draw the face of this triangle. We have DVC, and we have this length as 8, and we don't have DV or VC, but we have VO and VM. So we have this length, VM, as 9.46. So in this case, we will use some trig ratios. Now, if you notice, because dv and vc are equal length, so we have an isosceles triangle, it's always useful to divide an isosceles triangle in half, and you'll end up getting a right angle triangle. So that's a very useful property to use. So in this case, you have a right angle triangle, which means we can make use of these trig ratios. Remember, you can only use these when you have a right angle triangle, and you can come up with them either by finding them clearly or making them from other triangles. So in this case, isosceles triangles. So we have we're looking at this triangle here. And we have the right angle triangle here, and we're trying to find this angle, and then we'll double it to get the other side. So we have the base here. We know M is the midpoint, so this will be 4. We know VM, which is 9.46. So this is 4, 9.46, and we have this angle that we're missing. So I'm just going to label the triangle now. I'm just going to hide the other part of this triangle. I'm going to label our triangle. So this will be opposite, and this will be the adjacent, and obviously we don't really need the hypotenuse. So in this case, we will have to use the tan formula. And so we have that tan of the angle we don't know equals to the opposite, which is 4 divided by the adjacent, which is 9.46. In this case, we can't avoid not using the 9.46, so we'll have to use it there. And so this implies that the missing angle is tan inverse of 4 divided by 9.46, which will give us 22.92 something something. But remember that you need to double this. So angle, or let's use proper math notation, so angle DVC is equal to 2 times this 22.92, which is equal to 45.8 degrees. So that's the final answer. Try to make sense of the answer. Remember to always multiply by 2. Write the instructions in the beginning. Remember to multiply by 2, for example. That's one of the common mistakes students make. So now we get to the big part of the question, which is finding the surface area and the volume of the pyramid. So the surface area is you basically finding the area of every single face and adding them all up. So the faces we have currently in this pyramid are 4 identical triangles and then 1 square base. So in order to find the area of the one of the triangles, so if you notice we have, again, this is the face of one of the triangles, the base is 8. Now the height that we have, the VM height, is a perpendicular height. It's right angle to the base, so we are allowed to use it in the area of a triangle formula. So this was 9.46, and the base will be 8, and so the area of one triangle is half. So this is the surface area, is half times the base, which is 8, times the height, which is 9.46. But we have 4 of these faces. We have 1, 2, 3, 4 identical ones. Now, because they're identical, I'm just going to multiply this by 4, and then the last area I'm looking at is the square base at the bottom, so that's just 8 times 8. And being careful, very careful with the brackets and all, you should end up with 215 centimeters square. Remember the units. And for the last part, we need to find the volume. You need to find the volume, giving your answer correct to the nearest centimeter, which means you need to round it to a whole number. So the volume of a pyramid, this formula is given in your data booklet, so you don't need to remember it, is half times area times height. This refers to the area of the base, and this refers to the perpendicular height. Very important, because I could take the slanted height, a VM, or the slanted height VD, or I could take VO. It's always VO because that's the height that's 90 degree to the base. VM and VD are not 90 degree to the base. And so, sorry, it's not a half, it's a third. It's a third. It's a third times the area of the base times the height, so it's a third times area of the base is 8 times 8, and the vertical perpendicular height, we found it already in part A as 8.58. Just in there, 8.58. And so the whole thing rounded obviously to the nearest centimeter should give you 183 centimeter cube. Hopefully this video was useful. Finding surface area and volume are quite direct. Just plug in the formula for surface area. Just remember all the tiny parts that you have to add. And the long parts in these questions are just managing to find all these tiny, all the other lengths and making sure you're using the correct ratios. Try to practice more questions on finding pyramids. You can find similar questions at the end of the chapter from your book in the paper 1 and paper 2 style questions.